At 0903 hours local time, a formation of Ukrainian FP-1 fiber optic attack drones moved silently through the low clouds above the Crimean Peninsula, approaching one of Russia's critical railway supply routes, connecting the mainland with Crimea. The target was a heavily guarded logistics train transporting fuel reserves and military supplies toward Russian forces stationed on the peninsula. The train was moving along the Moscow-Simferopol railway corridor, carrying dozens of fuel tank cars designed to maintain the operational capability of Russian units in Crimea. For Moscow, this railway was more than just a transportation route. It was a strategic lifeline that allowed fuel, ammunition, and equipment to continue flowing toward one of Russia's most important military regions, despite increasing Ukrainian pressure on logistics networks. However, Russian crews monitoring the route did not know that the train had already entered a carefully prepared strike zone. Within minutes, a group of Ukrainian FP-1 drones would approach from multiple directions, bypassing traditional defenses and turning the fuel convoy into a massive inferno near the gateway to Crimea. The operation relied on a coordinated network of FP-1 drones equipped with fiber optic control systems, allowing operators to maintain communication even in an environment filled with Russian electronic warfare activity. Unlike conventional radio-controlled drones that could lose connection due to jamming the fiber optic FP, one maintained a stable data link throughout the final approach, giving Ukrainian operators precise control while flying at extremely low altitude. Before the strike, reconnaissance assets monitored the railway corridor, identifying the exact position of the locomotive fuel wagons and vulnerable sections of the train. Thermal sensors detected the heat signatures of engines and fuel containers, while optical cameras provided detailed images that allowed operators to confirm the target before committing the attack drones. The FP-1 strike group then accelerated toward the railway formation using terrain features, darkness, and low-level flight to reduce the chance of early detection. Their compact design and small radar signature made them difficult targets for many traditional air defense systems, while the fiber optic guidance system reduced the effectiveness of Russian electronic countermeasures. As the drones closed in on the train, Ukrainian operators adjusted their trajectories in real time, selecting the most valuable targets. Fuel cars carrying hundreds of tons of supplies became the primary objective because destroying them would not only damage the railway infrastructure but also create a long-term disruption to Russia's ability to sustain military operations in Crimea. The final approach lasted only seconds. Multiple FP-1 drones entered the defensive perimeter almost simultaneously, striking the fuel wagons and critical parts of the railway convoy. The explosions ignited stored fuel, creating a rapidly expanding fireball that engulfed several sections of the train and transformed a routine supply mission into one of Russia's most damaging logistical failures in the region. The FP-1 fiber optic strike drones relied on a combination of satellite navigation, inertial guidance, and real-time reconnaissance data to maintain their attack formation and continuously update the train's position during the final approach. Even though Russian electronic warfare systems were active across Crimea, the fiber optic control system allowed the UAVs to maintain a stable connection with Ukrainian operators, reducing the risk of losing control during the most critical phase of the mission. Unlike conventional FPV drones that depended heavily on radio communication, the FP-1 was designed specifically for long-range precision attacks against heavily defended targets. Each drone was built for a one-way mission, carrying enough explosive power to damage critical sections of the railway convoy while maintaining high maneuverability during the final seconds before impact. The FP-1's compact airframe combined lightweight construction with powerful electric propulsion, allowing the drone to accelerate rapidly and perform sudden directional changes while flying at extremely low altitude. Its flight control system continuously adjusted motor output, stabilized the aircraft against wind disturbances, and maintained accuracy while approaching a moving train through difficult terrain. Every part of the design served a single purpose: survive the final approach, bypass electronic interference, strike the most vulnerable sections of the logistics, train and create a chain reaction capable of destroying fuel storage cars and disabling the railway supply route toward Crimea inside a Ukrainian forward command center positioned far from the strike area. Operators began analyzing every piece of reconnaissance data transmitted from surveillance assets, tracking the Russian convoy. The railway line stretched across the Crimean landscape, where thermal imagery revealed a long, moving heat signature cutting through the cold surroundings. The source was the Russian logistics train. The locomotive generated a powerful thermal signature from its engine system, while the fuel wagons remained warmer than the surrounding environment, making them clearly visible through infrared sensors. This allowed Ukrainian operators to identify the exact position of the train, even during darkness and poor visibility. All information, including coordinates, movement speed, direction, and target confirmation data, was transferred through encrypted communication channels back to the command post. The secure network reduced the possibility of Russian electronic warfare units locating the control elements or disrupting the final stages of the operation. Only seconds later, the Ukrainian strike system began calculating the final attack pattern for the FP-1 drones. The train's speed route and vulnerable sections were analyzed before the attack order was transmitted to each drone operator. The objective was not simply to hit the train, but to achieve maximum damage by selecting the most critical fuel cars and creating a synchronized strike. However, the most important element was timing. For nearly 2 days before the operation, Ukrainian reconnaissance assets had monitored activity along the railway corridor connecting Russia and Crimea. Analysts studied the movement patterns of Russian logistics trains and identified a predictable weakness in the route. According to the collected intelligence, the fuel convoy regularly reduced speed and temporarily stopped near a military-controlled railway section close to the entrance of Crimea. These short pauses were designed as part of Russian anti-sabotage procedures, but they also created a rare opportunity. A stationary train carrying hundreds of tons of fuel became the perfect target for a coordinated FP-1 fiber optic drone strike. That moment represented the most valuable attack window of the entire operation. As the Russian logistics train reduced speed while approaching a controlled railway section near Crimea, the fuel wagons remained in a predictable formation long enough for the FP-1 fiber optic drones to finalize their attack. Calculations. A slower-moving target gave Ukrainian operators more time to adjust flight paths, identify vulnerable sections, and synchronize multiple drones for a coordinated strike. Once the train's position was confirmed, the FP-1 drones simultaneously entered their terminal attack phase. Each UAV carried an explosive payload designed specifically for penetrating critical infrastructure targets. The objective was not simply to damage the outer structure of a fuel wagon, but to create an internal explosion capable of igniting stored fuel and triggering secondary destruction throughout the entire railway formation. A successful impact against a fuel carriage could transform the entire train into a massive chain reaction. Hundreds of tons of fuel stored across multiple wagons created a highly vulnerable target where a single penetration point could spread fire through connected cars and disable the railway route used to supply Russian forces in Crimea. As soon as the final targeting data was approved, the first FP-1 drone accelerated away from the formation. Flying only meters above the railway corridor, it descended into the attack profile while maintaining a stable fiber optic connection with the operator. Other drones followed behind, maintaining their assigned positions and waiting for the exact moment to strike. Above the battlefield, reconnaissance assets continued tracking the train's movement, providing updated information on speed, direction, and position. Every change in the convoy's movement was analyzed and transmitted through secure communication channels, allowing FP-1 operators to continuously refine their approach even while the target was moving. However, the attack was becoming increasingly difficult. After several Ukrainian drone strikes against Russian logistics networks, Russian railway commanders had modified their operating procedures. Trains no longer followed predictable movement patterns. Drivers frequently changed speed, accelerated unexpectedly, and applied brakes at irregular intervals to complicate drone targeting. Even a small change in speed could force an attacking UAV to adjust its trajectory by several meters during the final approach. Inside the FP-1 control system, the live video feed showed the railway line rapidly approaching as the drone flew at extremely low altitude. The operator constantly corrected the flight path, keeping the fuel wagons aligned in the center of the targeting view. The fiber optic connection provided a major advantage during this phase. Unlike conventional radio-controlled drones, the FP-1 remained connected even as Russian electronic warfare systems attempted to disrupt the battlefield environment. Navigation updates, camera signals, and operator commands continued flowing through the physical fiber optic cable extending behind the drum. As the distance narrowed, Ukrainian operators carefully monitored every detail. Reconnaissance systems confirmed that the fuel wagons remained in the same formation identified during earlier intelligence gathering. The final coordinates were transmitted, the attack route was verified, and the strike authorization process began. The target was locked, the approach angle was stable. The FP-1 drones were seconds away from entering the final dive toward the railway convoy. But then the situation changed. Only a few kilometers from the railway line, Russian electronic warfare units activated an R-330 system positioned near the route, creating a pre-established defense zone designed to protect critical logistics movements toward Crimea. Mounted on a military vehicle platform, the R-330 immediately began broadcasting powerful interference across multiple frequency bands. Its objective was to disrupt drone communications, interfere with navigation systems, and force the attacking UAVs away from their intended target. Russian operators believed the electronic shield would break the Ukrainian attack formation before the FP-1 drones reached the train. They expected the UAVs to lose control, drift away, or become ineffective under heavy jamming. But they underestimated one critical factor. These were not ordinary radio-controlled drones. The FP-1 fiber optic attack drones continued advancing toward the target while maintaining a stable connection through their resistant guidance system. Inside the Ukrainian command post, electronic warfare warnings appeared across monitoring screens as the drones entered the strongest Russian jamming zone. Russian systems attempted to overwhelm the attack formation with wide-area interference, cutting communication, and disrupting coordination between the drones and operators. When this failed, the R-330 began scanning multiple frequencies and focusing its jamming power against communication channels commonly used by conventional UAVs. Against traditional FPV drones, this tactic could have been decisive. Loss of video feed or control signals during the final approach would force operators to abandon the attack. However, the FP-1 was designed for exactly this battlefield environment. Unlike standard radio-controlled UAVs, it used a fiber optic communication link connecting the drone directly with the operator station. Control commands and video transmission traveled through the fiber cable, making the system far less vulnerable to electromagnetic interference and allowing the drones to continue toward the Russian logistics train. Inside the command post, operators saw electronic warfare warnings continue to appear, but the connection with the FP-1 drones remained active. The video feed experienced temporary disruptions from the surrounding electromagnetic environment, yet the control link was never completely lost. Realizing that traditional jamming was ineffective, Russian electronic warfare units attempted another method. Instead of only blocking signals, they began generating false navigation data designed to confuse UAV positioning systems and push drones away from their intended route. The goal was to create a false battlefield picture, making the drones believe they were drifting away from the railway target while gradually forcing them off course. However, within seconds, the FP-1 navigation system detected inconsistencies between satellite positioning data and the drone's actual movement. The flight computer compared incoming navigation information with data from internal sensors, including acceleration, speed, heading, and altitude measurements. When the system identified that external positioning data was unreliable, it automatically reduced dependence on satellite navigation and switched to alternative guidance methods. Inside each FP-1 drone, inertial navigation systems continued calculating movement using onboard sensors. Accelerometers and gyroscopes tracked every change in direction and speed, allowing the UAVs to maintain their attack path even while the electronic battlefield around them became increasingly hostile. On the command screens, Russian jamming indicators continued flashing, but the FP-1 formation remained stable. The drones continued advancing toward the railway corridor, following the route previously identified through reconnaissance. Instead of relying only on satellite coordinates, the FP-1 guidance system combined sensor, data, camera, imagery, and previously collected intelligence from reconnaissance platforms. Railway tracks, power lines, bridges, road intersections, and other terrain features became reference points that helped confirm the drone's position during the final approach. The lead FP-1 continued flying low along the railway line, unaffected by the electronic shield that Russian operators had prepared. Then only seconds later, the forward camera captured a critical landmark. This was the exact location Ukrainian intelligence had monitored for days. Below, the Russian locomotive began reducing speed as the train entered the controlled section of the railway route. Fuel wagons behind the locomotive started slowing down, creating the precise attack window Ukrainian planners had been waiting for. Inside the Ukrainian command center, every operator focused on the live feed. The target was approaching the predicted position. The train's speed matched intelligence estimates. As soon as the convoy slowed to the expected speed, the FP1 targeting systems activated simultaneously. The drones adjusted their final approach paths, locked onto the designated fuel wagons, and prepared to enter the last stage of the attack. Trained on thousands of reconnaissance images collected from previous surveillance missions, the FP1 targeting system was able to identify different elements of the Russian logistics train within seconds. The onboard computer quickly distinguished the locomotive, fuel wagons, military, supply cars, and the distance between each carriage, allowing the strike formation to select the most vulnerable points along the convoy. The artificial intelligence system analyzed the structure of the train in real time, calculating which fuel cars would create the greatest secondary damage if successfully hit. At the same time, the network assigned different targets to each FP1 drone, preventing multiple UAVs from striking the same location and reducing the overall effectiveness of the attack. The Russian train would remain inside the controlled railway area for only a short time before continuing toward Crimea. Ukrainian operators knew this was the best opportunity to strike while the convoy was moving slowly and the fuel wagons remained in a predictable formation. The FP1 drones completed their final target lock and entered attack mode, waiting only for the command from the Ukrainian control center. At 0426 hours and 20 seconds local time, the encrypted strike order was transmitted. The lead FP1 drones accelerated, lowered altitude, and separated from the formation while maintaining their fiber optic connection. 2 drones moved toward the rear section of the logistics train, targeting fuel and military supply wagons identified during reconnaissance. The targeting system analyzed the shape, heat signature, and position of each carriage before confirming the selected wagon as a high-value objective. Seconds later, the first FP1 reached attack distance and accelerated directly toward the railcar. The explosive payload detonated on impact, penetrating the outer structure and creating a powerful internal blast. Metal fragments scattered around the railway line as flames briefly erupted from the damaged compartment. However, the massive chain reaction Ukraine expected did not happen immediately. The targeted wagon was not carrying exposed fuel. Instead, the internal compartment contained protected military equipment packed inside reinforced containers. The explosion caused serious structural damage, but the energy was absorbed by the cargo arrangement and protective materials, preventing the blast from spreading to neighboring cars. Inside the locomotive cabin, the Russian driver immediately recognized that the train was under attack. He pushed the throttle forward, attempting to move the convoy away from the vulnerable inspection area before additional FP1 drones could reach their targets. The diesel engine produced a sudden roar. Steel wheels accelerated along the tracks, and the long line of railway cars began pulling forward toward Crimea, attempting to escape the ambush zone. Above the battlefield, Ukrainian reconnaissance systems immediately analyzed the result of the first strike. Thermal imagery showed a damaged wagon with a localized fire, but the fuel cars behind the locomotive remained intact. The expected secondary explosion had not occurred. The Ukrainian commander immediately ordered the remaining FP1 drones to continue the attack and pursue the moving convoy before it could leave the engagement area. The operation was entering a new phase where every second would determine whether the remaining drones could reach the fuel wagons before Russian crews escaped. However, the first impact had already created another problem for the Russian train. The penetrating strike severely damaged the structure of the rear wagon. A large section of twisted metal had collapsed downward, becoming dangerously close to the wheel system and continuously scraping against the railway track. The convoy was still moving, but its speed and stability had already begun to deteriorate. Each time the Russian train attempted to increase speed, the damaged section of the rear carriage created additional resistance. Twisted metal continued grinding against the railway track, producing a constant stream of sparks while slowing the entire formation. The locomotive engine was operating at maximum power, but the convoy could no longer accelerate as planned. It continued moving forward at reduced speed. creating a critical opportunity for the remaining FP-1 fiber optic drones. Above the railway corridor, the surviving FP-1S immediately changed from attack formation into pursuit mode. They descended to extremely low altitude, flying only a few meters above the ground while following the railway line. Maintaining their fiber optic control links, the drones accelerated toward the damaged convoy and began closing the distance before the train could escape deeper into Crimea. At 0427 hours local time, the FP-1 formation reached the rear and side positions of the moving train. Reconnaissance systems tracked the convoy using thermal imagery to identify damaged wagons and remaining fuel compartments that could create the greatest impact. Within seconds, the targeting system selected 2 priority fuel cars, one near the front section and another closer to the middle of the formation. These targets offered the highest chance of creating secondary explosions and disrupting Russia's supply route toward Crimea. At 0427 hours and 20 seconds, 2 FP-1 drones separated from the formation and approached the fuel tanker from different angles. One struck the center section, while the second attacked a weaker, lower area where critical fuel components were concentrated. The 2 drones detonated almost simultaneously, penetrating the outer structure and rupturing the fuel compartment. Escaping fuel vapor quickly transformed the area into a highly flammable zone, and within moments the wagon was engulfed in flames. A massive fireball expanded around the train as the shock waves spread through nearby carriages. Extreme heat, increased pressure inside adjacent fuel tanks, causing additional fuel vapor leaks and triggering secondary fires across the convoy. The flames spread through multiple connected wagons, turning the railway formation into a corridor of burning fuel and destroyed equipment. Smoke and heat distortion reduced visibility, forcing reconnaissance systems to rely on thermal imagery to track remaining targets. While the front section of the train burned additional FP-1 drones continued advancing toward the next priority, fuel cars. But once again, the situation changed. The damaged rear section of the convoy suddenly shifted as the deformed metal frame continued dragging against the railway track. The unexpected movement caused the target carriage to move away from the predicted impact point within seconds, forcing the FP-1 operators to rapidly adjust their approach paths during the final stage of the attack. The battle for the remaining fuel cars was entering its most critical phase. The first 2 FP-1 drones missed the intended fuel compartment after the train suddenly changed position, striking the connection area between 2 rail cars and detonating outside the main target zone. However, the Ukrainian strike formation quickly adapted. The next pair of FP-1 drones redirected toward another high-value carriage deeper inside the convoy. The new target was a military supply wagon carrying ammunition and equipment capable of causing a powerful secondary explosion if penetrated. At 0427 hours and 50 seconds local time, the first FP-1 accelerated through the smoke-filled railway corridor and struck the center of the cargo carriage, creating a breach in the outer structure. Less than a second later, the second drone followed the same path, hitting the weakened area and detonating deeper inside the compartment. Initially, the explosion appeared limited, but within seconds, heat and fragments reached the stored military materials. Internal pressure rapidly increased, triggering a chain of secondary explosions that tore through the railway car. The blast wave threw heavy steel fragments across the tracks, while flames rose above the train and merged with the existing fires from the fuel wagons. Multiple attack points began combining into one expanding destruction zone across the railway formation. But the operation was not finished. The remaining FP-1 drones continued toward the rear section of the convoy, targeting another critical military supply carriage that had avoided the previous explosions. This section of the train was still partially intact, making it the last major target capable of affecting the overall outcome of the strike. At 0427 hours and 57 seconds local time, the final FP-1 drones descended to extremely low altitude and accelerated through smoke-falling debris and intense heat surrounding the railway line. Their fiber optic control links remained active despite the chaotic battlefield environment. The first drone struck the outer structure of the rear carriage, creating a weakened impact point. The second followed almost immediately, entering through the damaged area and detonating deeper inside the compartment. A massive explosion erupted at the rear of the train. The blast wave spread through the remaining carriages, sending flames in both directions as the last section of the logistics formation disappeared inside a growing fireball. At this point, the convoy was no longer burning from a single impact. Fire was consuming the front, center, and rear sections simultaneously. Within less than a minute, multiple fire zones merged into one continuous wall of flames stretching across hundreds of meters of railway track. The coordinated FP1 strike had transformed a Russian logistics convoy into a major battlefield disaster. By 04:02, 8 hours local time, the Russian logistics train carrying fuel and military supplies toward Crimea had been almost completely destroyed. Burning fuel, damaged equipment, and dangerous debris turned the railway corridor into a hazardous zone. But the impact extended far beyond the train itself. The FP1 strike damaged a critical logistics route supporting Russian operations in Crimea and the southern front, destroying supplies while severely damaging the railway infrastructure. Russia could not simply remove the wreckage and reopen the route. Engineering teams would need to clear fires, remove destroyed wagons, and repair damaged tracks, a process that could take days or even weeks while remaining vulnerable to additional Ukrainian drone attacks. A single destroyed section of railway created a major supply bottleneck. Fuel, ammunition, equipment, and spare parts moving toward Crimea would be delayed, forcing Russia to rely more heavily on road transport. However, replacing a large military train with truck convoys would require significant resources and create new vulnerabilities. Road movements would become easier targets for Ukrainian reconnaissance, drones, artillery, and long-range strike systems. The disruption would also affect Russian forces beyond Crimea. Reduced fuel and ammunition supplies could limit artillery operations, restrict armored movement, and delay the arrival of reinforcements on the southern front. Russia would also need to strengthen air defenses around key logistics sites, potentially moving S-300 and S-400 systems away from other areas and creating new weaknesses in its defensive network. The significance of the operation was not simply the destruction of one train. The FP1 fiber optic drone strike demonstrated a wider strategy, transforming Crimea from a secure military rear base into a vulnerable logistics zone where every train, fuel, convoy, and supply mission faces increasing danger. 9 FP1 drones overcame electronic warfare attempts, penetrated the defended railway route, and exposed the weakness of the supply network connecting mainland Russia with Crimea. The objective was not only to destroy equipment, it was to attack the logistics system that keeps an army operating. What was the most important factor behind this operation? The FP1's resistance to electronic warfare, the precision of target selection, or the decision to strike directly at Russia's logistical lifeline toward Crimea? Share your thoughts in the comments.